Previously, we introduced how to use the for loop to solve the problem of square root. In this video, we will redo this problem but in a slightly different way. This time we are using a while loop. First, let's cut and paste our original code into a Jupyter notebook. Now we will write a new solution and submit it. This solution is correct. Let's take a look at the fourth line, I plus equals 1. To figure out the meaning of this statement, we can go over to the Jupyter notebook and define a variable called a. Then assign 1 to a. Let's run a by itself. The result is 1. In the next line, we will write a plus equals 1 and run the code. Then run a by itself. The result is 2. Next, let's write a plus equals 3 and run this code. Then run a alone, the result is 5. From these results, we can conclude that in Python, the plus equal sign sums up the values of both the left and the right side, and then assigns it to the variable on the left. This means that a plus equals 1 is actually the same as a equals a plus 1. This is one of the special notations in Python that you need to know. To elaborate further, we can copy the whole function over to the Jupyter notebook. Under the fourth line, let's add a print statement to print the values of I squared, and num. Now let's call the function with 77 as the input value and run it. From these results, we can see that the while loop works just the same as the for loop. Both of them will increase the value of I until I squared is greater than num and then exit the loop. Yet these two loops are different in many ways. The setup for the starting index, exit condition, and step size are all different. Take this function for example. The starting index is I equals 0, which is in line 2. The ending index is written after the word while in the third line, meaning as long as I squared is less than num, the function will continue to run the code under the while statement. The step size is set in line 4. Each time the while statement runs, the value of I increases at an increment of 1 until I squared is greater than num, where the loop will then end. You might be wondering, why do we still need a while loop if it works just the same as a for loop? Let's examine it in the case of the square root problem, where the loop will end once I squared is greater than num. If we use a while loop to solve this problem, we can set an exit condition in the loop itself. However, if we use a for loop, we will still need to set an ending index to exit the loop. On top of that, the ending index must be greater than the exit condition in a for loop. For example, in the original for loop that we wrote for this problem, we set the ending index as num plus 1. If we were to change the ending index to num instead, when num is equal to 1, the for loop will end without meeting the exit condition. So, in order to solve this type of problem, the while loop is more concise and easier to understand than the for loop. However, there is a downside. Since exit condition and step size are set separately in a while loop, people sometimes forget to set the step size. For example, if we comment out I plus equals 1 in the fourth line and run it, we will see that the value of I never increases. And because I squared is always less than num, the loop continues endlessly. This is called an infinite loop. You should be careful to avoid this type of error in coding. To sum it up, this Python tutorial is aimed at helping you master the basic Python statements and logic. Although there are better solutions to this problem, it requires you to have a deeper understanding of algorithm knowledge. As beginners, mastering these solutions are enough for you to handle the daily work. But if you wish to learn more about coding, I suggest you take our Interview Python Basics courses, once you can complete Python 39 by yourself.